So in chapter 6, we're going to be measuring everything in radians. We're not going to be measuring them in degrees any longer. Let me go ahead and share my screen here. So the first one actually is in degrees. So remember when we graphed these, we went ahead and when it was a positive angle, we went counterclockwise. So 510 is greater than 360. So I'm going to subtract it to see how much past 360 I need to go. Once I subtract that, I get 150. So when I go to graph this or draw this angle, I'm going to go around one full circle and then 150 degrees more. And this is how you would graph that angle. Now, notice the arrow here. When you were doing the WebAssign homework last night, if they gave you a question, for example, number 3, if it was a negative angle, when you go to graph this one, your angle is going to go this way. So if your answers, and they were asking you to find the measures of them, if your angle was drawn clockwise, then your answer should have been negative. So just keep that in mind. And I'm going to show you, that was more on when you were looking for the arc measure and they were asking you to find theta. But I'll cover this one in a minute.
Ms. Corey?
Yes.
Do you have to draw like the little line that shows that you went around, or can you just draw like the final line?
I want to, if it asked you to graph that angle, you would have to show the swirl around. If you were only looking for the reference angle, then you wouldn't have to. But if it actually asked you to graph this angle, yes, you would have to show the swirl.
Okay, thank you.
All right. Now, just like before, we're going to be looking for reference angles. So when we went 150, we went 90, then we went 60 more. So remember, your reference angle is what it takes to complete the triangle back to the x-axis. So that's how you would graph that. Now, let's say we wanted to convert this into radians. Yesterday in the notes, you learned how to convert from degrees to radians. So we would take 510 and we're going to multiply that by pi over 180. I can simplify this and I can reduce this, divide these both by 30, and this becomes 17 over 6. So if it asks you to convert it to radian measure, that's what you would do. You would multiply it by the conversion, which is pi over 180. Now, let's say they ask you to figure out what the reference angle is in radians. Instead of turning it into a degree and subtracting, remember we're subtracting 360 to get a reference angle. What we can do here, yesterday you were shown that 2 pi is equivalent to 360. And just to show you how they figured that out, so if you have your circle here, and let's say I told you, that's off. Let's say the radius for this circle, and this is what you're going to see in the unit circle that I'm going to show you today. The radius length, no matter where I draw it, has a length of 1. If you recall, and this is supposed to be equals 1. If you recall your circumference formula, the circumference formula is 2 times pi times the radius, or pi times diameter. But here, if I times 2 by pi and by the radius, which is 1, my circumference of this circle is 2 pi. So that's how they figured out that a degree of 360 is equivalent to 2 pi. So let's go back here now. Yes.
Mateo says to let him in on his other device.
Thank you. Got it. All right, got him. Okay, thank you. All right, so that's what we're doing here. So instead of subtracting 360, I'm going to subtract 2 pi. And this is where my knowledge of fractions comes in. 17 pi over 6, I need a common denominator of 6. So I'm going to change 2 pi into 12 pi over 6. Subtract, and I get 5 pi over 6. And then that would be my 150-degree angle. And we're going to see this coming up on the unit circle. Let's try the next one. Again, it's in radians. So if it's easier for you at the beginning to convert it to degrees, you could do that. The conversion from radians to degrees would be 180 over pi. Cancel. Cancel. 14 times 60 is 840 degrees. So in order to graph this, I'm going to be subtracting 360. Get 480, subtract it again, and I get 120. So I'm going to go around the circle 2 times. Once, 360, 720, and then I need to go another 120 degrees to get to the 840. And again, put the arrow so you know which way you went. Again, if we were doing the calculations in radians, what we would do is you're going to take the 14 pi over 3, subtract 2 pi. Again, I need to find a common denominator. So 14 pi over 3, common denominator 3, 2 pi becomes 6 pi over 3. 8 pi over 3. It's still not an angle between 0 and 360. It's still too big. I need to subtract 2 pi one more time. So still same denominator. And now I finally get something that is an angle measure in radians that's between 0 and 2 pi. You're going to become familiar with what angles are in between 0 and 2 pi. We're going to take a look at the unit circle. Generally, when we don't have people at home and everyone is in the classroom, you memorize that unit circle and the angles that are on it. Here, I would have a picture of a unit circle and have it as a quick reference guide. So 2 pi over 3, this is actually 120 degrees. Let's try the next one. Here's my negative angle. So here what I'm going to do is if I wanted to convert it into degrees, just to see what it is, I'm going to multiply it by 180 over pi. Pi's cancel. 3 and 180 will simplify. And I'm left with negative 240. So notice here I went around 90, 180, and then I went 60 degrees more to make it to the negative 240. So again, here's my reference angle, it's 60 degrees. So again, if I took my negative 4 pi over 3 and I want to get it into an angle in between 0 and 2 pi, I'm going to add 2 pi to this to get it to be positive. And I'm going to add 6 pi over 3, which gives me 2 pi over 3, which again, you can see is this angle for this terminal side, which is the 120 again. If I were to draw it positive and go this way. So these are coterminal angles. Number 6 was the same as number 2. Let me go over here to number 4. I know I've written in that area. So again, if we wanted to convert it, just to see, because we're so used to degrees, cancel. 5 goes into 180 36 times. 11 times 36 is 396. So if I graph this, I'm going to go around one full circle and then a little bit more. And again, in radians, 11 pi over 5, subtract 2 pi to get my reference angle. And then this would become 10 pi over 5, which becomes pi over 5. So my reference angle right here is pi over 5. One last one. before we go on to the length of the arc and the area of the sector. So again here, if I want to see degrees, cancel, 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 45. 19 times 45 is 855. I'll do it on this one that's here. So again, way too big. I gotta subtract some 360s here. 495, do it again, 135. So I'm gonna swirl around once, 360, 720, and then now another 135 degrees, giving me my 855 or my 19 pi over 4. My reference angle is the 45 degrees, and we're gonna learn to see that that's gonna be pi over 4. But over here, if I keep subtracting the 2 pi's, I would get something on the unit circle, 11 pi over 4. So, 19 pi over 4, subtract 2 pi. 8 pi over 4 gives me 11 pi over 4. Still too big. Keep going. Subtract another 2 pi. And then I end up with 3 pi over 4, which is equivalent to 135 degrees. All right, so let's look now at finding the arc length or finding a missing piece. So this seems to have been the biggest trouble part with the homework last night. So when they give you theta, theta must be in radians. So the formula to find the length of the arc is going to be S is equal to radius times theta. So what I'm going to do here is I don't know the length of the arc. My radius is 12. My theta is 140. But what I'm going to do is instead of, you can either convert it ahead of time. I'm just going to do the conversion right here in the problem. Because to convert degrees to radians, you multiply it by pi over 180. Now, if it says to give the exact value, then you're going to leave your answer in terms of pi. If it says to use a calculator and round your answer, then that's when you'll touch your pi button. So here I could simplify the 140 and the 180. I can change this to a 7 and this to a 9. I can also simplify again with the 12 and the 9, make that a 4, make that a 3. So exact answer, 4 times 7, 28 pi over 3. If it says using your calculator and using your pi button, and these are centimeters, you can also say that 28 times pi divided by 3 is 29.32 centimeters. If it said to round to the nearest hundred. For the area of this same question, the formula I'm going to use is going to be, and I'm going to do it down here, and then I'll do number 8 on its own. Area is 1/2 radius squared theta. So 1/2, 12 squared, still the 140. Again, I still need to make it into radians. I'm going to simplify. I'm going to square that 12. And now this will simplify to 7 pi over 9. I'm going to reduce, make that a 72. Can reduce one more time, make this an 8. So then my final answer here is going to be, did I mess something up? This should have been, I did it the wrong way. The 8 should have been up here on the 72. And this should have been a 1. And now 8 times 7 pi is 56 pi centimeters squared, its area. Now, again, if they say to multiply it by pi using your calculator, then we would get 175 rounded to the hundreds, 0.93 centimeters squared. So if it says give exact, then you're just going to put the pi symbol there. If it says approximate, then you use your pi button. Now let's do number 8, and then I'll talk about common things that people asked about in the homework. So this one's asking us to find the measure of the central angle, and you had to do stuff like this in the homework. So in the homework, so the formula again for arc length is S is representing the arc length, radius times theta. So they gave us the arc length this time. It was 19 centimeters. They gave us the radius, and we don't know theta. So if they just asked us to leave it, then our answer for theta is 19/8. Some people entered decimals and they got it wrong. So for the homework last night, they wanted you to leave it as a fraction. If they said to write it as a decimal, then theta would have been about 2.375, and these are both radians. Now, in the homework last night, they also gave you pictures. So just to clarify a few things here. On some people's, this was like their number 15. And they gave you a picture like this. And they had theta here. They gave you the radius. And then they gave you the length of the arc. And again, they said to find theta. So again, you would just take S is equal to radius times theta. The arc length is 4, the radius is 3, divide by 3, and theta equals 4/3. And that's all you had to do in the homework. Now, some people, like when you get to number 18, and also keep in mind the direction. They drew arrows in here. When the arrow goes counterclockwise, this answer is positive. If you had a question that looked like this, and 7 was the radius, and now the angle goes this way, and then they gave you the arc length here of 24, realize your angle is going clockwise, so theta is negative. So what you should have done here is S is equal to radius times theta, but remember, theta is going to be negative when we're done. So, because it's going clockwise. So if I put in the numbers, 24 is equal to 7 times theta, divide by 7. Theta is negative 24/7. There were some questions where they gave the radius in centimeters, and then they gave the arc length in meters. You need to make the units the same. So if you didn't pay attention to the units, that's why you might have gotten this question wrong. So like for example here, I'm gonna make my meters into centimeters. I use the rhyme, King Hector drinks basically delicious chocolate milk. Whatever trick you want to use for converting, you probably have already done dimensional analysis in chemistry. You should have done this in middle school. So to convert from meters to centimeters, 2 jumps. So I'm going to take my 0.2, move it twice. So 0.2 meters equals 20 centimeters. So now when I go to put it in my formula, S equals R times theta. Now what I can do here is do 0.2 is equal to, well, actually no, I'm going to make it 20 now because I converted it. 20 is equal to 17.5 times theta. Divide both sides by 17.5. And now I have 20 over 17.5 equals theta. I can't leave this like this. I need to simplify this fraction by moving this decimal point once, put 1 here, move it once. Now I have 200 over 175. And now I can reduce this. I can divide them both by 25. I know there are 8 quarters in $2 and 7 quarters in 175. So theta is 8/7. So watch your units. This was last night's homework. Any questions on 6-1? All right, look for the notes on 6-3. I'm only going to do a little bit today.